Good morning, students. Now we'll be looking at a new topic from your light lesson. So please take your textbooks. It is on page number 66. So, what is light generally? Light is a source of energy. So, what happens here is we'll be talking about reflection of light first. So, do you know what reflection means? Imagine you're standing in front of the mirror, and what do you observe on the mirror? You see your reflection, isn't it? You see yourself. That is called as reflection. So, in case of light rays, what happens here is the for example, imagine that you are holding a torchlight and you switch on the torchlight while standing in front of the mirror. What will happen? The light will reflect, isn't it? So kindly imagine this image I'm showing on this slide has the concept I told you, like you're holding the torch and you're showing it on the mirror and the light gets reflected. The same concept applies here. So what happens here is the ray passing from the left side of you is called as the incident ray. So on the slide, the left side red color line, the ray is called as incident ray. That is, you're passing the torchlight beam, you're switching it on. That ray is called as the incident ray, and the reflected ray is called as reflected ray. So on the slide, the right side line is called as reflected ray. Yes. So could you understand this image? The incident ray is touching the mirror and it gets reflected. So the initial ray is called as incident ray, and the ray reflected is called as reflected ray. So I would like you to introduce to a word called normal. So what does normal mean in image formation concepts is that normal means nothing but perpendicular. So in mathematics you would have studied what perpendicular means, isn't it? It is in 90 degrees formation, that is normal. So in this image, could you see the dotted lines, vertical dotted lines? That is the normal ray. Yes, normal. So from the normal, the angle of incident ray is called as the angle of incidence, which is denoted by the letter small I. So the angle of reflected ray from normal is denoted by R, which is the angle of reflection. So this is the image explanation for laws of reflection. So what are the two laws of reflection here we have? The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane, isn't it? The incident ray, the reflected ray, normal all lie on the mirror. So, all lie in the same plane. So, the second law of reflection is that the angle of incidence is equal to the angle of reflection. Nothing but in the box we have written on the right side. Could you see I equals to R? That is the second law of reflection. The angle of incidence is equal to the angle of reflection. So we have two types of mirror, concave and convex. First, we'll only be seeing what is concave mirror and the image formation by concave mirror. So we have totally six cases in this image formation by concave mirror. We'll be only looking at the first three. Yes. So the first case here we have is, I'll explain. So the first case is, imagine any object like a candle. Okay, a candle. So in this image, could you see A and B, the vertical line? A and B, the vertical line, that is image, that is the you can imagine that it has candle. So the candle is placed at some point in front of a mirror. So could you see the mirror, the point P? The point P is called as the pole of the mirror. The line extending towards the object is called as, from P, it is called as principal axis. C stands for center of curvature and F stands for principal focus. Yes, C for center of curvature, F for principal focus. So imagine an object. For example, you can imagine a candle. Yes, a candle is placed in front of a concave mirror. So the object is placed at infinity. For now, you imagine that as a candle. So what happens here is, could you see the blue dotted lines? Yes, the dotted lines, yes. From A, one line is passing, and from B, one ray is passing, and it touches the mirror surface and it gets reflected back, isn't it? It touches the mirror and it gets reflected back and passes through F. Both the lines passes through F, isn't it? This is not line, this is, you should refer it as ray. Okay, because this is light unit, we are talking about light. So both the rays are passing through F. F means what? Principal focus. So what happens here is the image is very diminished. So you get the reflection while placing an object in front of mirror, you get reflection, isn't it? So in this case, when this object is at infinity, what does infinity mean? At a very large distance, at a very long distance. It is not measured at all. At a very long distance. What happens here is the object is very small, like dot, small dot will be found. Okay, so it is called as diminished, very diminished image will be formed. So the next case, we'll move on to the next case, second case. So could you observe the object A and B? Where is it placed? The object is placed between infinity and C. Yes. So the object is placed left side to the C, center of curvature. C stands for center of curvature. So the red line AB is the, imagine that is any object like candle, a tree, or a toy, any object. It can be any object. So we are placing it between infinity and C. So what happens here? The light rays are passing. One ray is passing through principal focus. Yes, and it's going. Another ray is passing through center of curvature and it is reflected back. So where these two rays, reflected rays, meet is that here. Yes, object is placed between infinity and C. So one ray is passing through principal focus, another ray is passing through center of curvature and it is reflecting back. So the intersecting point is where the image is formed. Could you see it is inverted? Yes, AB, and it is inverted here. So the image is comparably small when compared to the real object, isn't it? Yes, this is about the second case. Now we'll move on to the third case. What happens here is, in the first case, where did we place the object? It was at infinity, isn't it? And in the second case, previous case, where was the object placed? Between infinity and C. Now we have come to third case. So the object is placed at center of curvature C. So could you see two rays are passing? So one ray is passing and it gets reflected and it goes through the principal focus. Another ray is passing through principal focus. It gets reflected. So where does these two rays meet? It meets exactly down to the object, isn't it? So could you yes, could you observe that the reflected? Could you observe that the image formation is of the same size as compared to the object? Yes, it is inverted, but both the object and the image formed is of the same size. Yes. So the where was the object placed in case 3? It was placed at center of curvature. Yes. So now we saw case 1, case 2, case 2, and case 3 we saw. So this is the summary of the three images, the ray diagram we saw. First diagram, where was the object placed? At infinity. Where was the image formed? At principal focus. And how was the image? It is where it was real and inverted and diminished. Yes. What about the second case? The object was placed beyond C. Where was the image formed? We got the image between F and C. Again, it was real, inverted, and diminished. In the third case, the object was placed at C and the image was also formed at C. C for center of curvature. What about the nature of image? Real, inverted, and the same size we got. Yes, students, for your follow up work, I want you to draw all these three ray diagrams in this format on your classworks. Okay. So in the next class, we'll be studying about the remaining three cases. We totally have six ray diagrams under concave mirror and one under convex mirror according to your syllabus. So we'll be studying the another three ray diagrams in the next class. Okay. So I have divided this the whole topic into two because you could understand it very clearly. So because you have to remember this ray diagram. Yes. Yes, students, meet you in the next class. Thank you.